Hi, welcome back to another Reel of Study Core Tutors, and yet again I'll be doing another problem solving video. And topic wise, yes, it is physics. I love physics. And recently I went on to ChatGPT to generate me some random physics problems, and in this night we're gonna go through them and solve them. Now I have pulled up a question here and we're gonna try to solve it together. So a 10-kilogram box is being pulled across a horizontal surface by a rope that applies a force of 50 newtons at an angle of 30 degrees above the horizontal. The coefficient of kinetic friction between the box and the surface is 0.2. Find the acceleration of the box. Now we know what we're trying to look for, which is find the acceleration of the box. But how do we get there? And now, first things first, what I would do is I would draw out my diagram. So we have your 10-kilogram box, 10 kilograms, and the tension that is being pulled at, which is 50 newtons. But we also have to consider that it's being pulled at an angle, hence 30 degrees. And now that we got our free body diagram drawn, or just a diagram of what it looks like and what we're trying to do here, we can now try to find out and solve to find acceleration. So first things first, we need to find the total weight of the box. Now, you're probably asking, wait, but they already gave us the weight because 10 kilograms. No, because the total weight, because the box is on a flat horizontal surface and it's on Earth. And what do we have on Earth? Gravity. And we know for a fact that this box is on a flat horizontal surface, which means gravity will be acting upon it. So in this case here, to find the total weight, our formula would be weight is equal to mg, weight is equal to mass times gravity. And we just input the values, so we know that the mass is 10 kilograms and gravity is equal to 9.8. kilograms, 9.8, and that will be a total of 98 newtons. The work is being, the weight is being affected due to gravity. And now that we have our total weight, now we can move on and try to solve for the other components to help us get acceleration. In this case here, we're going to need our x and y components. And the x and y components tell us the calculations, or like the newtons or the forces that are acting on each other from horizontal or vertical, like the forces being acted on a horizontal surface, whether it's like from left to right or if it's vertical, up to down. So in this case here, it's horizontal, so we just need to calculate both components. So sum of Tx, tension, is equal to Tx cos angle, which is theta. Ty is equal to Ty sine theta. And now we know that, but from this question, we know that the box is being pulled by 50 newtons. So that will be the tension. So sum T of x is equal to 50 cos. And it's pulled at an angle of 30 degrees. And Ty equal to 50 sine 30 degrees. Now we just input this into our calculator. Now 50 cos of 30 is equal to 43.3 newtons. And 50 sine 30 is just 25. And now that we have both our x and y components, now we're going to need to save this for later. But from now, we're going to have to move on and try to calculate our normal force. So the normal force, so 3 normal force So that is our F net W minus T. You're probably wondering what W minus T is. It's basically F net is basically the weight subtracted by the tension. So in this case here, we already have our total weight, which is 98, and the tension, well, T of X, because the box is being pulled on a horizontal surface, so it's being pulled from left to right. In this case here, it's being pulled on the right because the value of the tension is positive. So F net is equal to 98 minus 50. Therefore, F net is equal to 73 newtons. Now that we have our normal force, now we can use it to find our friction force. I should probably use a different color for this now. We'll go with teal. So friction force the formula for that is Fk is equal to mu k and net force, or normal force. And because we found our normal force, which is 73 newtons, which will play an important role to find our friction force. And in the question here, they already gave us the value of the friction, which is 0.2. So in this case, we just multiply them together to get our friction force. So F of K is equal to 0.2 multiplied by the normal force, which we calculated was 73. Therefore, friction force is equal to 14.6 newtons. And now that we have that, now we can apply the Newton's law, specifically second law. So our F nets. So, oh boy. I'm just going to change some colors here. Hold on. Okay, there we go. Now for part 5, Newton's second law. So in this case here, F net is equal to Tx minus kinetic friction. So this will give us our second law. So F net is equal to 43.3. 43.3, if you're wondering, where did you get 43.3? We took that for the x and y components when we calculated. Then we subtract by the friction force, hence our friction force is a value of 14.6 newtons. And you just put that into a calculator. Altogether, you would have 28.7 newtons. And now that you have your values, now from here we can try to calculate our acceleration, and that formula being F is equal to ma, some force is equal to mass times acceleration, or so in here we have some force is equal to F is equal to ma. But in this question, we're trying to look for acceleration of the box. So in this case here, we're going to have to rearrange the formula. So we bring the acceleration to the front because acceleration is what we're looking for. So it would then become acceleration is equal to some force divided by the mass. And the mass of the box before is 10. So therefore, A is equal to some force divided by mass is equal to A is equal to 28.7 divided by 10. Therefore, the whole question, acceleration is equal to 2.87 meters per second squared. And that is how you solve this whole problem. Thank you for joining me on this beautiful night. And like always, my friends, happy studying.